In this short video, I'm going to show you how to handle a linear correlation coefficient problem in section 9.1 homework in MyLab. In this particular problem, I'm dealing with one of the later ones, number 9.1.33, and we're going to show you how to handle it and compute it using StatCrunch. So you can see the problem is listed right here. We have all the description. We have 6 vehicles. 1, 2, 3, 4, 5, and 6. And we want to know if there is a significant linear correlation between the weight and variability in braking distance. So I already have the entire problem shown for you. So our HO says that they are equal to 0. So the correlation coefficient is 0, which means there isn't any relationship. And the HA is not equal to 0, which means there is some sorts of relationship and going on here. So what we're going to do is we're going to show you basically how to click your buttons. Of course, we click on right here, and this is going to open it up in StatCrunch. We're going to do that here in a second. Click here to view a table for the critical values for a t-distribution. Well, we have an alpha of 5%, and we have 1, 2, 3, 4, 5, 6, which means that we have degrees of freedom of 5. We have a two-tailed test because of equal and not equal. So if I click on the table over here, we got a two-tailed test, 5%, and if we slide down to our degrees of freedom is going to end up being 4. Okay, I got 1, 2, 3, 4, 5, 6. Our degrees of freedom are being 4 because I got to take out 1 for the x and 1 for the y. So we got negative 2.776 and positive 2.776. We pulled that number from our table right here. We got our critical values listed up. Now let's figure out how you're going to get your test statistic. So what we're going to end up doing here is I'm going to hit your StatCrunch, open in StatCrunch just like you're used to by this point in time, and my data pops right up. So now it's time to actually sit down and find the test statistic for a linear correlation. So I'm coming to Stat, Regression, and we're going to choose Simple Linear. When I choose Simple Linear, it wants to know what is my x variable. So let me slide this over here. So my x variable is the weight. My y variable is the braking distance because my x variable is my independent. It's what I choose. My y variable is my dependent. It's the result. Okay, we have the hypothesis test. We're just going to leave everything else alone. We're not going to change anything else on this. And we're going to hit the compute. So now what ends up happening is we got some numbers here. And not all of these numbers are going to be used. We're going to talk about more of these numbers later in section 9.2 and 9.3. But what we're going to pay attention to right now is the actual test statistics, since we're trying to see is there a significant linear correlation. We're going to come down here to the line that says slope, and we're going to look at this right here. There's my test value, which is 1.406. That's what we're looking for, is the actual slope for that particular value. So 1.4065, that's how they get the 1.407 that you see right here, because we are testing a slope to see if there is a correlation between the two, and is it a strong correlation. So then with our test value, we look only at the slope. We get the 1.407. That is our value that we plug in here, and then we have to make our conclusion. Does our 1.407 fall outside of our two values that you see here? 1.407 falls in between. Since it falls in between, there is not enough evidence. We failed to reject the HO. There is not enough evidence to conclude that there is a significant linear correlation. Now, there might be a slight correlation, but it's not significant. In order to be significant, it either needs to be outside of the 2.776 on this end or outside on the other end. So again, how did I do that particular test? I come over here. I'm going to show you one more time. We're going to go to Stat, Regression, Simple Linear. I pick my independent variable, the weight, could be anything I want. Pick my dependent variable, what happens after I choose the dependent, the independent. I hit compute, my number comes out. You can see my degrees of freedom right there is the 4. That's how I got the test statistic. And right here, I'm looking at, right there, I'm looking at 1.4065. That's my test statistic. That's what I'm putting in for the t. So that's how you do a simple linear regression problem when you're trying to run a hypothesis test on it. This covers StatCrunch for section 9.1.